Hello dear students, I am Ronak Kumar, your physics faculty at Aakash, and a very warm welcome into this session in which we are going to discuss the paper AIATS plus 2025 phase 2 mock test 4B that was conducted on 9th of February 2025. And I will be taking the problems based on these chapters, which is current electricity, motion in straight line, kinetic theory, thermodynamics, alternating current, and electromagnetic waves. Important chapter from the point of view of NEET examinations, and you must expect a lot of problems from these chapters. Now let's move forward towards our first problem, and it's right there on your screen. It says that, and this problem is based on the chapter of current electricity, and the problem is of the meter bridge. It says that a wire is connected in the left gap of a meter bridge balance. A wire is connected in the left gap of a meter bridge balance, a 10 ohm resistor in the right gap to a point which divides the bridge in the ratio 3:2. The resistance of the wire is. So you have been given a setup of meter bridge, and in the right gap there is a 10 ohm resistor. In the left gap a wire is connected, and the jockey or that point of null deflection, it divides the length in the ratio 3:2. So you need to find the resistance of the wire, right? Now if I try to show you how does a meter bridge look, a meter bridge looks like this. So this is the basic setup of a meter bridge. You have your right gap, over here, you have your left gap over here, and if this is the jockey, then it is dividing the length. If this length is L1, then this length will be 100 minus L1, right? Now according to the problem, you have 10 ohm resistor, in the left gap, and you have connected a wire in the right gap. So over here you have a wire, and this jockey, if it touches over here, it divides this length in the ratio. If this is 3K, then let it be 2K. So that is how the problem has been designed. Now you need to find the resistance of this wire. So dear students, we all know that this meter bridge works on the principle of balanced Wheatstone bridge, right? So on the basis of balanced Wheatstone bridge, what I can write is that, if I go by this, I can write that R, okay, let me assume that the resistance of the wire that we need to find is R. So R over, if I go R over 3K, it should be equal to, this S is 10 ohm, so 10 ohm over 2K, right? So if I try to solve this, it could be written as R over 3K to be equal to 10 over 2K. Let me cancel this K and K. So from here I can write that R is coming out to be equal to 10 by 2 into 3. This implies R is coming out to be equal to 15 ohm. Simple problem. The resistance of wire is coming out to be equal to 15 ohm, and it is given to you in option 1. Right? I hope you understood the problem. Now, this meter bridge, it works on the principle of balanced Wheatstone bridge, as I told you. So you can write the resistance of this much part of the wire as rho into L1 over A, right? What is rho? Rho is the resistivity, A is the area of cross section, L1 is the length of this much part, and for this much part you can write the resistance as rho into 100 minus L1 upon A, right? So that's how you can write the resistance of the wire. Now based upon this concept and the concept of meter bridge that we just discussed, there was a problem asked in the actual NEET examination which looks like this. It says that a resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the wire in the ratio 3:2, right? If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire will be. So you need to find the length of 1 ohm of the resistance wire, and you have been given 4 options like this, right? So the problem is very similar to the problem that we did before. You can see that it is dividing in the ratio 3:2. In the left gap there is a resistance of okay, there is a resistance of 10 ohm in the left gap, and a wire is connected in the, 10 ohm is in the right gap and a wire is connected in the left gap. So this is the setup. Over here, again you have 10 ohm resistance connected over here. You have a wire over here. And again, this ratio of dividing the length is 3K and this is 2K. So based upon our calculation we did for the balanced Wheatstone bridge, I wrote that R upon 3K, it should be equal to 10 over 2K. So from here, R was coming out to be equal to 15 ohm, right? Now, length of the resistance wire is given to you as 1.5 meter, right? So we know that resistance of a wire, it is written as rho into L over A. Rho is the resistivity, L is the length, and A is the area of cross section. I hope you know all these terms. So rho is your resistivity, L is the length, and A is area of cross section. Right? So R is equal to rho L by A, and this is, so you need to find if the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire. Now, according to the problem, 15 ohm is the resistance when resistivity is rho, length is 1.5, and area of cross section is A. Right? Okay. And if the resistance of the wire is now, okay, if the length of the, okay, now if the resistance of the wire is now 1 ohm, in that case, again, resistivity will be rho, length you need to find, and area of cross section still remains A because the wire remains A, right? So anyone, if you are getting the answer, you can put the answer in the comment box. Meanwhile, I'll solve the problem for you. So basically, when 15 ohm is the resistance, then the length of the wire is 1.5. They're asking you when 1 ohm is the resistance, what should be the length of the wire, right? So if this is my equation 1 and this is my equation 2. So from equation 1, what I'll do is I'll take out the value of rho by A. Rho by A, it is equal to 15 over 1.5, right? And I'll put the value of rho by A in equation 2. So I can write that over here. I can write that 1, it should be equal to rho by A is 15 over 1.5 into L. This value L is what I need to find. So from here, I can find that L is equal to 1.5 by 15. And it is equal to 1 by 10 or 1 into 10 raised to the power minus 1 meter. This is the correct answer to this problem, 1 into 10 raised to the power minus 1 meter. Now, let's go through the problem. Okay, so what should be the correct answer to this problem? It should be option 3, not 1, not 2, not 4. It should be option 3, 1 into 10 raised to the power minus 1 meter. Yeah, not 1, someone is commenting the answer as 1, not 1, it should be 3, right? Okay, let's move forward. I hope I cleared the concept of the meter bridge. Let's move to the second problem of the original paper. This was the problem 19 of the original paper, again on the chapter of current and electricity, and the topic will be Kirchhoff's laws, and this problem is based on the Kirchhoff's junction law, which says that incoming current, this is based on the concept that incoming current should be equal to outgoing current. Okay, so the current in branch AC of the given circuit is, so you need to find the current in the branch AC of the given circuit, and this is my point A. I'll take this as my junction. Right, this is my junction, and if I try to, the incoming current at the junction is, what is the incoming current at the junction? It is equal to 4 ampere, right? Okay, someone is commenting the answer. Outgoing current at the junction, outgoing current is equal to 3 plus I. 3 plus I. So according to the junction law or from the charge conservation, I can write that 4 should be equal to 3 plus I, which means that the value of I should be equal to 1 ampere. That means current in the branch AC of the circuit is 1 ampere, as we just did the calculation, and it's a simple problem, just the basic application of Kirchhoff's junction law, and you are good to go. So correct answer to this problem should be option A. 2, 3, 4 and wrong, right? Okay, very good morning to all of you. Yes, now let's move forward to the next problem of this session, and there you go. Now this problem is based on the chapter of electromagnetic waves, again a very important chapter from the point of view of NEET examinations. And the problem says that what is the order of energy of X-rays, radio waves and microwaves. So you need to compare the order energy of X-rays, microwaves, X-rays, radio waves and microwaves, right? So dear students, to compare the order, first you know how do you compare the energy of an electromagnetic wave. So energy of an electromagnetic wave, E, it can be written as H into F. H is your Planck's constant, F is the frequency. E is equal to H into F or SC by lambda you can do, but H into F, F is the frequency. Now you very well know that there is a certain frequency range for X-rays, there is a certain frequency range for radio waves, and there is a certain frequency range for microwaves. Now whichever will be having the higher frequency will have the more energy, and whichever is having the lower frequency will have the less energy. So if I need to compare the X-rays, radio waves and the microwaves, what I need to basically do is I need to compare the frequencies of all these three. And to compare the frequency, I need to be thorough or clear with the the spectrum of the electromagnetic wave. So this is the spectrum of the electromagnetic wave right in front of you. First you have the gamma rays followed, okay, let me clear one thing first. This is the frequency part and it is in the decreasing order, as you can see. Have a look at the right side. This is the frequency part. It is in hertz and it is in the decreasing order. So maximum frequency is for gamma rays, followed by X-rays, followed by ultraviolet, followed by visible, followed by infrared, then microwaves, then short radio waves, and you have the television and FM radio, AM radio, and then you have long radio waves. So you need to basically compare three electromagnetic waves, X-rays, then you have the microwaves, and then you have the radio waves. Now, based on the spectrum of the electromagnetic wave, I can see that the X-rays, this X-ray is having the maximum frequency among the three. That is, X-ray, you need to compare this X-ray, microwaves and radio waves. And this is the decreasing order of the frequency. It means that the maximum frequency is for X-rays. Yes, so maximum frequency is for X-rays. So X-rays is going to have the maximum energy followed by the microwaves. And microwaves will be followed by the radio waves. Right? So we were denoting the energy of X-rays as EX. We were denoting the energy of microwaves as EM. And we were denoting the energy of the radio waves as ER. So if I need to arrange it in the decreasing order, it should be EX should be greater than EM and EM should be greater than ER. That is the correct order which you need to answer, right? So this is the frequency and this is the order of the wavelength. More is the frequency, lesser is the wavelength. That is the basic concept of waves. More will be the frequency, lesser will be the wavelength. And this is the spectrum of the visible part of the EM waves. Now, let's move to the problem. So, order of energy, we just, based on our calculation, order of energy is what we are required to find, and it is coming out to be option 2, that is EX is greater than EM is greater than ER. So this one is wrong, this one is also wrong, and this one is also wrong, right? So I hope I cleared this concept, how to compare the energy of the electromagnetic waves. Basically, three were given to you, X-rays, radio waves, and microwaves. Now, based upon this concept, a similar problem was asked in the NEET examinations. Not a very recent one, but they have asked a problem which looks something like this. There you go. This is the problem of the actual NEET examination, which says that the energy of the electromagnetic wave is of the order 15 kilo electron volt. So you have been given the order of the energy, that is 15 kilo electron volt, to which part of the spectrum does it belong? So you need to figure out that to which part of the spectrum this energy will belong, and you have been given 4 options: gamma rays, X-rays, infrared rays, and ultraviolet rays. Now you need to utilize the similar concept that we discussed in the previous problem, that is the energy of the electromagnetic wave E, it is equal to H into F. F is your frequency, right? Now the order given to you in the problem is 15 kilo electron volt. So 15 into 10 raised to the power 3, and 1 electron volt, it is equal to 1.6 into 10 raised to the power minus 19 joules. So 15 into 10 raised to the power 3 into 1.6 into 10 raised to the power minus 19 joules. If I try to get the order, it is 15 into 1.6 into 10 raised to the power minus 16. So the order is, this 10 raised to the power, it is varying as 10 raised to the power minus 16. Now, let's have a look at the spectrum. I'll rub this part. I'll rub this part first. And my order was coming out to be equal to the energy which has been given to me, 15 kilo electron volt. It was coming out to be equal to 15 into 1.6 into 10 raised to the power minus 16. And we know that the energy, it is given as H into F, right? So H into F, H is Planck's constant, its value is 6.634 into 10 raised to the power minus 34, and into the frequency. Now what should be the order of the frequency, so that this energy terms, it is of the order 10 raised to the power minus 16. 10 raised to the power minus 16, so frequency should have an order of 10 raised to the power 18 hertz. Frequency, if frequency is of the order 10 raised to the power 18 hertz, in that case, this energy will be in the order of 10 raised to the power minus 16, and that's how you can get the answer. So if I have a look at the spectrum, I can see that 10 raised to the power 19 to 10 raised to the power 16. This part is covered by the X-rays. It means that this 10 raised to the power 18 hertz, it should belong to X-rays. And if this is X-rays, it means that this part of energy, it should belong to X-rays. That is option 2 should be the correct answer to this problem. Option 2 should be the correct answer to this problem, right? I hope you understood how to solve such kind of problems. Yes, energy is inversely proportional to wavelength. Yes, energy is inversely proportional to wavelength and directly proportional to frequency. So dear students, I hope I cleared this concept, how to discuss how to deal with the problems of electromagnetic waves, which ask you to compare the energy. Besides that, you also get a problem on the basic properties of the electromagnetic wave, the phase difference between the electric and the magnetic field, how to find the velocity. Now let's move forward to another problem. Again, a problem based on the chapter of current electricity, and this problem, they are asking you to find the equivalent resistance between across XY. The problem says that effective resistance of the circuit shown in figure across XY is. So you need to find the effective resistance across the point XY, right? So what is the basic concept that you need to keep in mind for solving such problem? That effective resistance in a parallel combination, it is equal to, okay, effective resistance in parallel combination 1 over R effective, it is equal to 1 over R1 plus 1 over R2 and so on. And for this is for parallel combination, and for the series part, R effective, it is equal to R1 plus R2 and so on, right? Okay, someone is commenting the answer. If you are getting the answer, you can put your answer in the comment box. We'll verify it. So for the series part, it is R1 plus R2, and for the parallel part, it is 1 over R1 plus 1 over R2. Now the problem is how to identify whether they are in series or whether they are in parallel. So have a look at so what is the concept behind this? That if the potential difference across the resistance remains same, then they are in a parallel combination, and if the potential difference is not same, the current is same, then they are in series combination, right? So have a look at this. this is your point X and this is your point Y. You need to find the equivalent resistance between point X and Y, right? So this is 10 ohm, this is 20 ohm, and this is 20 ohm. They are connected across this. Let me name this as A and B. So this 20 ohm and 20 ohm, they will have the same potential difference, which means that they are in parallel combination. And for the parallel combination of this, the effective resistance will be 1 by 20 plus 1 by 20, that is equal to 2 by 20, that is equal to 1 over 10. It means that for this part, our effective is coming out to be equal to 10 ohm. Right? Now, this point is B, this point is C. For this part, again, they are in parallel combination because the potential difference across both of them is same. So for this part, the effective resistance will be equal to 1 over 10 plus 1 over 10, that is equal to 2 over 10, and this is equal to 1 over 5. So R effective in this case is equal to 5 ohm, right? So let me redraw the circuit for you. This is your point X, and you have your 10 ohm resistance over here. The equivalent of 20 ohm and 20 ohm is 10 ohm. It is something like this. This is your 10 ohm. And then you have 10, 10, 5. So you have 5 ohm. And then you have your Y. So this is your Y. This point is C. This point is okay. This is X and A. I guess this is okay. So let me redraw this again. So this is X. This point is A. Between A and B, you have 10 ohm. This is your point B. And between B and C, or C or Y, you name it as Y only. So this is 10 and 10, 5 ohm. So you have 10 ohm, 10 ohm, and 5 ohm. They are in series combination. So that means that R effective for this case will be equal to 10 ohm plus 10 ohm plus 5 ohm. 10 and 10 is 20 plus 5, that is 25 ohm. And they are in series combination. Because if you try to see that current across all of these will be same. So 10 ohm plus 10 ohm plus 5, that is 25 ohm is the equivalent resistance between point X and Y, as you can see. So correct answer should be option 3. Not 1, not 2, not 4. Option 3 is the correct answer to this problem, right? So 25 ohm is the correct answer. And I hope you understood how to deal with the concept of series and parallel. But you cannot expect such easy problems always in the NEET examinations. Let me show you a problem which was asked in the recent NEET examination, and this is the problem from the NEET 2022 part. This problem is based on the concept of infinite ladder network. So infinite ladder network is one of the problems that you must practice for the examinations, as you can expect such problems in the NEET examination also. It says that you need to find the equivalent resistance of the infinite network given below. So this is the infinite network given below. And this is a special type of problem. This is a special type of problem. You just need to be thorough with the concepts and you will get your answer. So you can see that this is the infinite ladder network and we need to find the equivalent resistance. So let me assume that the equivalent resistance is R. Right? So if I try to break the circuit from here, from this point, I'm assuming that this right part, this line, the right part, the part which lies to the right of this line, it is having an equivalent resistance of R. So if I try to redraw the circuit, this is your 1 ohm. Again, this is your 1 ohm. And this is your 1 ohm. The circuit is repeating, as you can see that this is an infinite ladder network and circuit is repeating. So I'm assuming that this is my line and the part which lies to the right of this line, it has an equivalent resistance of R. So this is my R, right? And if I try to solve this, these two, they are in parallel combination. So their equivalent will be equal to R into 1 over R plus 1, right? So the circuit reduces to, this is your 1 ohm, and this is the equivalent part. This is 1 ohm. This now becomes R upon R plus 1. This is 1 and this is 1. What is the equivalent of all these three? These are in series combination. Now they are in series combination. So equivalent will be equal to R upon R plus 1 plus 1 and plus 1. Right? R upon R plus 1 plus 1 and plus 1. And it should again be equal to what? It should again be equal to R only, because it is an infinite ladder network. We broke the circuit from here. If the equivalent resistance of this part is R, then equivalent resistance of this part will also be equal to R, right? So this is what you need to solve to get the value of equivalent resistance. So if I try to solve this, this is R upon R plus 1 plus 2, and it is equal to R, right? So if I solve this, it becomes R plus 2R plus 2 to be equal to R square plus R, right? So just cancel this R, and you have a quadratic equation right in front of you which says that, okay, let me rough some part. Okay, I'll rough this part over here, and there is a quadratic equation which says that R square minus 2R minus 2 to be equal to 0. This is the quadratic equation that you need to solve to get the value of R, and I hope you all know how to solve a quadratic equation. Even if you don't know, I'll tell you how to solve the quadratic equation. So I'll rub this part is not relevant now, and let me rub this part also. So if I try to solve the quadratic equation, the roots of the quadratic equation, how do you find it? Suppose that quadratic equation is of the form x square minus bx. Okay. The roots are given as by this formula, minus b plus minus under the root of b square minus 4ac by 2a. Right? That's how you find the roots of the quadratic equation. Now, if I look at this quadratic equation, the value of b over here is minus 2. The value of a over here is 1. And the value of c over here is minus 2. Because the standard form of the quadratic equation is ax square plus bx plus c to be equal to 0. If you compare this with our quadratic equation, it is r square minus 2r minus 2 to be equal to 0. Now you can do a parallel comparison of both these equations and you will get to this part. So the value of b is minus 2, c is minus 2, and the value of a is 1, right? Now let's solve. So the value of r, it is equal to minus b. So b is minus 2, so minus minus 2 is plus 2, plus minus under the root of b square is 4, minus 4 into a is 1, and c is again minus 2. And divided by 2 times of a is what? 1, so 2. So if I solve this, it becomes 2 plus minus under the root of 4. 4 into minus 2 is minus 8, again 1 minus. So 8 plus 4 is 12 by 2. Right, take 2 to 2 as common, so it becomes 1 plus minus root 3. Okay, the value is coming out to be equal to, R has two values, 1 plus root 3 ohm and 1 minus root 3 ohm. Now we know that this is not the real value. This cannot be the value of the resistance because it cannot be negative. Root 3 is greater than 1. If I take this value, the value of R will be negative, which is not possible. So this one is wrong, which means that the value of R, it should be equal to 1 plus root 3 ohm. That is the correct answer to this problem, 1 plus root 3 ohm. Yes, 1 plus root 3 ohm is the correct answer to this problem. I hope I made this concept clear, how to deal with the infinite ladder network other than the regular problems of series and parallel combination, right? Now, Okay, now let's move forward to the next problem. And this is the problem again. Someone is commenting 2 hai iska answer. I have not shown any options to this problem. So you just need to find out the actual answer. And the answer is 1 plus root 3. Now let's move forward to the next problem. This problem is based on the concept of alternating currents, and you need to find. Let me go through the problem first. It says that in an AC circuit, current is given by the equation I that is equal to 4 sine 50t plus pi by 3 ampere, and voltage is given by 200 sine 50t volt. Average power consumed per cycle by the circuit will be. So you need to find the average power consumed for the cycle. So dear students, average power, P average, what is the formula for average power? Anyone can give me the answer in the comment box. It is Vrms into Irms into cos phi. This is the average power consumed, P average. It is Vrms into Irms into cos phi. Now Vrms, it can be written as the peak value of voltage divided by root 2. What about Irms? It can be written as peak value of current divided by root 2. And how to find the cos phi? You can have a look at the equation of current and the voltage. So current is given to me as 4 sine 50t plus pi by 3, and voltage is given to me as, see, current is given to me as 4 sine 50t plus pi by 3, and voltage is given to me as 200 sine 50t. So the value of phi, or the phase difference between the current and the voltage, you can see from here, it is equal to pi by 3. Phase difference is pi by 3. So cos phi, value of cos phi, it is equal to cos of pi by 3. What is the value of cos 60? A very standard value. What is the value of cos 60? Anyone can give me the answer in the comment box. The value of cos 60 is 1 over 2. So 1 over 2. So you are done with one part. The formula consisted of 3 terms. It consisted of Vrms into Irms into cos phi. So cos phi, its value is 1 over 2. Now you need to find Vrms. So the peak value of voltage is 200. So it is 200 by root 2. And Irms, again, peak value of current is 4. So it is 4 by root 2. So let us put the value now. So P average we need to find. Vrms, it becomes 200 by root 2. Into Irms, it becomes 4 by root 2. And cos 60 is 1 over 2. So it becomes 800 by 2 into root 2 into root 2, it becomes 2. So 800 by 4, or it becomes 200 watt. 200 watt is the power consumed per cycle for the circuit equation that has been shown to us, which means correct answer is option 4. Not these 3 are wrong. Right? Irms, Vrms, cos phi. Yes, very good. So that's how you find or deal with such kind of problems, and these are the kind of problems that you can expect in the actual NEET examination based on the chapter of alternating current, right? I hope I made this clear. Now let's move forward to next problem, and it's there in front of your screen. It is the problem based on the chapter of kinetic theory of gases, right? And it says that molar specific heat capacity at constant volume. So what is molar specific heat capacity at constant volume? What do we call this? We call this as CV. So basically you need to find CV for a linear triatomic gas. So you need to find the value of CV for linear triatomic gas, and the assumption is that you have to neglect the vibrational modes. So any degree of freedom which is associated with vibrational motion, you have to neglect that, and you need to find the value of CV for the linear triatomic gas. So dear students, CV, this is molar specific heat capacity at constant volume. Okay, CV, it is written as F into R by 2. What is F? F is your degree of freedom, DOF. So R is the universal gas constant. This has been given to you. So basically this problem reduces to the fact that how to determine the degree of freedom for the linear triatomic gas, ignoring the vibrational degree of freedom, obviously. So let's talk about the linear, you have linear triatomic gas. So linear triatomic gas. So dear students, linear triatomic gas, it will have, see, first thing first, it will have 3 translational degree of freedom. 3 translational degree of freedom. And it will have 2 rotational degree of freedom. Why 2? Because it is having a linear structure. Had it been a non-linear structure, the degree of freedom associated with the rotational motion, it will be equal to 3. So together it has 3 translational degree of freedom and 2 rotational degree of freedom. So 3 plus 2, it becomes 5. So total number of degree of freedom for this linear triatomic gas, it is equal to 5. Right, and it is similar to diatomic gas. So CV value, it should be equal to 5R by 2. Three translational degree of freedom, 2 rotational degree of freedom, total degree of freedom becomes 5. The value of CV, molar specific heat capacity at constant volume, it is coming out to be equal to 5R by 2. That means correct answer should be option 2. Now if you got the concept, if you are thorough with the concept, help me to get the value of CP. What should be the value of CP? Molar specific heat capacity at constant pressure for the same linear triatomic gas, ignoring the vibrational degree of freedom. Anyone can give me the answer in the comment box. What should be the value of CP? I got you the value of CV. Help me to get the value of CP. So how to get the value of CP when you have CV? CV is 5R by 2. Okay. So dear students, you can use the relation CP minus CV to be equal to R, or I can write that CP should be equal to R plus CV. R plus CV is 5R by 2, so it becomes 7R by 2. CV is coming out to be equal to 7R by 2. Okay. So that's how you deal with such kind of problems. You just need to be clear with the concept of degrees of freedom, then what should be the degree of freedom associated with different kind of molecules that has been asked to you, right? So I hope this point is clear to you now. Now let's move forward to the next problem. Again, this problem, okay, 7 by 2, yes. Not 7 by 2, it should be 7R by 2. Now again, this problem is based on the chapter of thermodynamics, and precisely it is based on zeroth law of thermodynamics. This problem says that if body A is in thermal equilibrium with different bodies B, C and D, then, okay, a body A is in thermal equilibrium separately with body B, body C and body D, then you need to compare these terms, whether B is in thermal equilibrium with C, whether B is in thermal equilibrium with D, whether C is in thermal equilibrium with D, or all the options are correct. So dear students, it is based on the concept of zeroth law of thermodynamics, which says that if two bodies are in thermal equilibrium, or then their temperature must be same, right? So according to the problem, TA, if A and B, they are separately in thermal equilibrium, which means that TA should be equal to TB, right? Because since A and B, they are in thermal equilibrium, it should mean that TA should be equal to TB. This is my equation 1. Okay. Now, body A is in equilibrium with body C also, which means that thermal equilibrium with, that means that TA should be equal to TC, because this body A is in thermal equilibrium with body C also. Let's talk about, again, Body A is in thermal equilibrium with body D also. So TA should also be equal to TD. Option. This is my question 3. Now mathematically TA is equal to TB, TA is equal to TC, and TA is also equal to TD, which means that TB is equal to TC, TB is equal to TD, and TC is also equal to TD. Now what is the meaning of TB is equal to TC? It means that body B and body C, they are in thermal equilibrium with each other. Let's talk about B and D. So if TB is equal to TD, it means that body B is in thermal equilibrium with body D. And if TC is equal to TD, it means that body C is in thermal equilibrium with body D, right? Now let's go through the options. So according to our analysis, TA is equal to TB, and based upon the analysis, TB was coming out to be equal to TC equal to TD. Right, TB was coming out to be equal to TC equal to TD. Now, B is in thermal equilibrium with body C. Yes, this one is correct because TB was coming out to be equal to TC. B is in thermal equilibrium with D. Yes, this one is also correct because TB was coming out to be equal to TD. C is in thermal equilibrium with D. Yes, TC was also coming out to be equal to TD. So all these three are correct. It means that the correct answer to this should be option 4. Yes. Yes, Chitra ji, yes, the correct answer should be option 4, all of these, right? Now, let's move forward to the next problem. There you go. This is the problem based on the velocity time graph. So, velocity time graph, it is coming from the chapter of motion in straight line, and the problem says that the velocity time graph for a body is straight line parallel to time axis, then its acceleration is. Okay, you need to comment on the acceleration based on the velocity time graph. Now dear students, we very well know that acceleration, it is equal to dv by dt. That is the slope of velocity time graph. Slope of velocity time graph will give you the information about the acceleration or the acceleration only. So according to the problem, the velocity time graph looks like this. This is my time, this is my velocity, and according to the problem, velocity time graph for a body is straight line parallel to time axis. So it is something like this. Now, can someone give me the answer to this? So you can see that velocity, if this is V naught, so as the time passes, time is passing, but there is no change in the velocity, or you can see that the slope of VT curve over here is 0. It means that acceleration should also be equal to 0. Slope of VT curve is 0, so acceleration should be equal to 0, or you can also do it mathematically. It says that V is constant. V is constant, that means that dv by dt, it should be equal to 0, which means that acceleration should be equal to 0. Right? So it means correct answer should be option 1, not 2, not 3, not 4. So if you have a clear understanding of the slope, so you can comment by looking at the graph that what should be the value of acceleration. Now if you are thorough with this problem, help me to solve this problem. And this is the actual problem from the NEET examination. It was asked in NEET 2022. It says that the position time graph for positive acceleration is. Now, you need to comment on the position time graph for the positive acceleration, and you have been given the xt graph. Now, slope of xt graph will give you the velocity, and slope of vt graph will give you the acceleration. So, acceleration should be positive, and based upon that, you need to comment upon the xt graph. See, v, it is equal to dx by dt, that is velocity is given by the slope of position time curve, and acceleration is given by the slope of velocity time curve, right? Now, what is the meaning of positive acceleration? What is the meaning of positive acceleration? Yes, someone is giving me the answer. Surya is giving the answer as A as well as B. No, it is not multiple correct, it is single correct. So answer should only be either one of these, A, B, C, and D. Now, what is the meaning of positive acceleration? The meaning of positive acceleration is that the velocity should keep on increasing, right? and velocity is given by the slope of xt graph. Now have a look at the first option. If I see over here, the slope of xt graph is negative as well as constant. For this part, the slope is negative. Slope is negative and constant. So if the slope is negative and constant, it means that the velocity is not changing. And if velocity is not changing, then there should be no acceleration. For this part, for this xt curve, no acceleration should exist. Acceleration should be equal to 0. So this is not the right answer. Let's talk about C first. So you can see that for positive acceleration, the concept is that the velocity should keep on increasing, and velocity is given by the slope of xt curve. So you can see that slope over here, over this point. Okay, I'll draw it over here. This xt curve is given to you as something like this. So you can see that the slope over here, it is equal to 0, and over here it is approaching to 90 degrees. So over here it is approaching to 90 degrees, over here it is equal to 0. So slope is somewhat getting from 90 to 0. From 90 to 0, it means that slope is decreasing, which means that velocity is decreasing, which means that it cannot be the case for the positive acceleration. Had the problem been asked about the negative acceleration, in that case, this would have been the correct answer. So this is wrong. Let's talk about the fourth one. It's a straight line curve passing through the origin. It means that the slope is 45 degree. It is the slope is, over here is positive and constant. So two options in front of you, they had the constant slope, either positive or negative. So the acceleration in two of the options will be equal to 0. One is denoting the negative acceleration, which means that the correct answer should be option B, right? Now, if you are not well versed with the concept of slope, then you can also solve this problem mathematically. The problem was being asked to use that acceleration was positive. Here, acceleration is equal to constant, which is greater than 0, right? Now, acceleration is given as dv over dt, and it is given to you as constant. So if I integrate this, v will become equal to ct. So v is equal to ct. It means that v should be equal to, okay, v is coming out to be equal to ct. V is equal to ct, and v is also equal to dx by dt. So from here, dx should be equal to ct dt, and if I integrate this, x should be equal to ct square by 2. X should be equal to ct square by 2. X is coming out to be equal to ct square by 2. What kind of a variation x is having with time? Can anyone name me the variation based upon this equation? This equation is parabolic. The variation is parabolic. And what should be the graph between x and t? There are two kinds of graph possible over here. You should know how to differentiate between the two graphs. This one is x and this one is t. So one of the graphs should be like this, and one of the graphs should be like this. Which one is the correct graph based upon this equation x, that is equal to ct square by 2? This one or this one? Anyone can give me the answer? So dear students, remember that, okay, just remember this. Okay, little bit of technical glitch. See, remember this, that if y is equal to kx square, this is the equation of parabola. This is the standard equation of the parabola. The graph is always symmetric. The graph is always symmetric about the single power, right? So over here, you can see that the single power is with x. So graph should be symmetric about x. So this should be the correct answer, not this one. This cannot be the answer. It would have been the equation had the equation be something like this. t should be equal to x square. If had this been the equation, this graph could have been the answer, but based upon our analysis, the graph should be like this. So if I try to draw, this is my x and this is my t, so graph should be like this. So graph should be like this, xt, right? So that's how you can deal with such kind of problems. Either you go mathematically, either you go with the help of slope. The slope part is difficult to understand, but once you understand the concept, you can reduce the number of steps in the actual examination, and time is the key factor in acing the examinations like NEET, where you have to attempt a lot of problems, and the time per problem is very less. So I recommend that you must be very clear with the concept of slope, because if you try to solve this problem with the help of slope, two of the options, they are having the constant slope, so you can very well nullify the two options, and only you have to now pick the answer between B and C. Again, with the help of slope, you can figure out that this C part cannot represent the positive acceleration because the slope is negative. Since the slope is negative, this cannot represent the positive acceleration. So the only part that can represent is option B. Now, if you are stuck in the actual examination, you can go with the other approach. You can form the equation and then you can get to the graph part, right? So dear students, I hope I made this part clear as well. Now with this, I'd like to end my sessions, and I hope that all the concepts, all the queries pertaining to these chapters, I cleared it. I tried to clear it, and if you have any queries, do let me know. And all the very best